All right, let's go over the 7.4 problems, reasoning using slope fields. So this first one, they're giving us a slope field for the differential equation dy dx equals x over y, where y is not equal to 0. We want to sketch the solution curve that passes through to point 3, -1. So we'll start with that. So 3, -1 is right here, the point they give us. So I'm going to start by going down this way. You just kind of follow along with the current. That's how I like to think about it, like it's a current. Go with the grain of the slopes. There's a hole right here because it's not defined at y equals 0, so we put a hole and we actually stop there. And then we do the other one. So this is the point 1, 2. I'm going to cross that out and write 1, 3 because the point that they give us here actually looks like 1, 3 to me, so that's what we're going to do. And again, you just follow along with the slopes. Don't think that you need to connect these lines. I've heard some people say that in the past, that they get a little hung up on trying to connect these lines. That's not what they're there for. They're just there to show you the direction that the slope is going in. So you just kind of go along with them, going in the direction that they're giving you. All right, next one is multiple choice. They give us a slope field. Which of the following could be a solution to the differential equation with the initial condition y of 0 equals 1? So that's where this point up here comes from right here. So x is 0, y is 1. So first thing I did here was I drew the best of my ability the solution curve by following along with the slopes given. There's a couple things that I noticed right away that I want to use to get rid of a few options. So first of all, we've got kind of this bell-like curve here. So I'm going to look at my options and see which ones could not possibly give me anything like this. So cosine, not so sure. I'll leave it in the running. 1 minus x squared, that's a parabola opening down. I'll leave it in the running. Y equals e to the x, definitely not. That's an exponential function, so it goes up like this. No, we're going to get rid of that. Let's just say, let's say I don't know what this looks like, so we'll leave it in the running. And we'll say I don't know what e looks like, so we'll leave that in the running too. Next thing I notice is that, now this is just something that helps me. This is how I think about this. So I want to pick a point that's on the line that I just drew. So when x is 1, here's my point on the function. Y should be something around 0.5. Because I'm pretty confident that I drew my solution curve as best as I could. So that should be correct, that if we plug in x, we should get something around 0.5. So I'm going to think about what happens when I plug 1 in. So that's what I had written down right here. So y equals cosine of 1. So even if I didn't know what that was, I do know that it's somewhere around 0.5, but just say I didn't. I'm going to leave it in the running just because I don't know if I don't have a calculator. I think it's something like 0.54, so it is pretty close. So we'll leave it. For b, if you plug 1 in for x, you get y equals 0. Nope, that's not an option. For d, if you plug in 1, you get y equals 0. Also not an option. For e, if you plug in 1, you get exactly 1/2. So we will leave that in the running as well. So we have 2 options left. So even if you're like totally stuck at this point, you got a 50-50 shot. But let's think about, I'm still pretending I have no clue what this function looks like. So I'm going to think about cosine because I do kind of know what cosine looks like. So one thing I know about cosine is that it starts at 1, which we have here, but it also crosses over the x-axis and goes into the negative y's over here before it curves and turns back up. This one, it's looks like it's curving down here, and it looks like it should go back up right here. So it's not crossing over the x-axis where it should. Actually, cosine x equals 0 at x equals 2, like I wrote right here. Sorry, at not x equals 2, at pi over 2. Pi over 2 is somewhere like right here and right here. Um, so if this were cosine, that would have to go through that point, come all the way down here, and then go up. So that leaves us with only this as our option. So that's why it's E. So you kind of want to use what you know about these functions in order to get the answer here. So you know me, of course, I'm going to say I love that question. I think it's pretty interesting. So this one, a number of frogs living in a pond is modeled by the function y equals capital F of t that satisfies the differential equation. I can read this right here. So this is actually called a logistic equation. It's not something we're going to talk about a whole lot, but it's something you might see in science or in a future class that you might take if you haven't seen it already. So the number of frogs in the pond at t equals 0 is f of 0 equals b, where b is a positive constant. So a slope field for the differential equation is shown in the figure above. So just essentially what's happening here is if you have over 1,000 frogs, that's too much for the environment, so the population is going to go down, and it's going to kind of taper off and go towards 1,000 because that's like the ideal amount. If you have less than that, then there's room for the population to grow in the environment, so it's going to go up, and then again it's going to taper off around 1,000 because that's where I guess that's where it's good. And that's about the extent what I know about frog population. So all right, back to the question. So they want us to sketch the solution curve that passes through the point 0 to 50. So that's down here. So we just go with the flow of the slopes given to us, and we cannot cross over that horizontal line because if we did, we would be going like very much against that slope. So you can't cross over it. You have to kind of go with it once you get to that point. It's a horizontal asymptote, so that actually does make perfect sense. If we start at 1500, it's kind of the opposite. We go down this way. I'm not doing a great job with my blue line here, but you see the point. And that's it for that one. Okay, so this one, basically they're just giving us a slope field and they want us to sketch 3 different solution curves. You can kind of see it here. Negative 4, 4 is up here. You just go with the slopes here. You've got a horizontal slope here around here somewhere. So that means we need to turn and go up. Whoops. And then you go along this line here. And that's, I guess I'll draw it in blue since I accidentally did that. So it goes up like this. And that's it for that one. Then we have 6, 2. So this one right here. So again, you just follow along with the slopes. That's a nice color. And then that's really all there is to it. For negative 2, 3, that one's a little odd because it's right on this thing that looks like a line. And if you follow the little slopes given to you, it's going to shoot you in one direction. So you can't go on either side of it. Otherwise, you'd be crossing over. So that solution curve is actually just a line. You just follow along with the slopes and it keeps pushing you in this direction, in this direction, this direction. So it's just a line. All right, next one. So you can kind of see what's going on here. I'm not going to redraw these. So in each quadrant, we've got what looks like perhaps like a vertical asymptote here, horizontal asymptote here. So you can kind of see what's going on. You just go with the slopes, follow them along. That's really all there is to that. 7 is a little odd. So we've got dy dx equals negative x over y. We need to keep in mind that it's not defined at y equals 0 because then you would have a 0 in the denominator here. So they're giving us these points. Let's start with, I guess we'll start with this one down here. So we just follow along with the slopes until we get to where there would be a hole, and that's where we stop. Same thing over here. You go until you get to a hole, and that's where you stop. Kind of the same deal with these. It's just they're above the x-axis, but you just keep going, following along. It's kind of making a half circle here, or a semicircle, until you get to the x-axis. That's where you stop because it's not defined there. And that's all there is to that one. It's a little weird, but just you have to keep in mind that wherever it's undefined, you just keep going and then you stop when you get to that point where it's undefined. Similar idea with this one. So we have x over y. It's not defined when y is 0 again. So let's start with this one down here because this doesn't pose a problem for us. We just follow along with the slopes like that. And then we never go to the x-axis with that one, so there's no issue. This one right here, up here, follow along up this way, go with the slopes, it's going up there. Then when we get down here at the x-axis, make a hole because it's not defined, and then that's where you stop. So this one up here, same idea. So this is another one of those ones where it's kind of making a line. So you have to stay with the line, and then when you get to the x-axis, you stop with a hole. And that's it. So now some FRQs. So these are good practice for the exam. So we're given a differential equation right here. F of x is the particular solution with the initial condition f of 0 equals 1. Okay. So a portion of the slope field is given below. Sketch the solution curve through the point 0, 1. So 0, 1 is right here. You just kind of go with the slopes. Maybe a little better than what I just did there. Go with the slopes. We've got a turning point here. Slopes become positive. They go up like that. Not positive, that's negative. Don't mind me. So negative slope, turning point, positive slope, turning point, negative slope. All right, so that's our sketch of the solution curve. It looks like a trig function, which makes sense because we've got a cosine in here. All right, so that's part A. Part B, write an equation for the line tangent to the solution curve at the point 0, 1. Okay, so that brings us back to tangent lines. So two things we need to write a tangent line. We need the slope of the line, which is going to be given by the derivative. In this case, the derivative is dy dx. We also need a point on the line, not a paint. We need a point. We need a point on the line, which we are given in this case. It's 0, 1. So really all we need to find is the slope at this point. So up here, that's exactly what I'm doing. So we have dy dx at 0, 1. We just plug in x is 0, y is 1 into dy dx because they give us an equation for dy dx. 3 minus 1 is 2. Cosine of 0 is 1. So 2 times 1 is 2, which means our slope of the line is 2. And then here I used my point and the slope to write it in point slope form. Y minus y1 equals m, x minus x1. And then just to make it look nicer, I put it in slope intercept, but you actually don't have to. They're not picky about that at all. So either of these would be appropriate answers. And then we want to use the equation to approximate f of 2/10. So we just plug in 0.2, substitute 0.2 into our equation. 2 times 0.2 is 0.4 plus 1 is 1.4, and that is your answer. So this next one is extremely similar. So we've got a slope field for this differential equation. We want to sketch the solution curve that passes through the point 0, 2, and sketch the solution curve that passes through the point 1, 0. So let's start with 0, 2. So that's up here on the y-axis. It's just a horizontal line if you're following along with those horizontal slope marks. And then at 1, 0, that's right here. We follow along with our slopes, kind of goes like this. Down here, kind of goes like that. And that is our solution curve at 1, 0. So then part B is really similar to part B in the last question. We've got an initial condition of 1, 0. So f of 1 equals 0 means we're looking at the point 1, 0. Write an equation for the line tangent to the graph of y equals f of x. at x equals 1, so they're trying to trick you there. So x equals 1, that's just telling us still that we're using the 0.10 because we know because they told us when x equals 1, y equals 0. So use your equation to approximate f of 0.7. All right, so basically what they're asking, you don't have to draw this, they didn't ask you to draw this, but what they're asking for is a tangent line at this point right here. So the tangent line should look a little something like this. So I'm just going to keep this in mind. Again, you do not need to draw that. Actually, if this were on the actual AP exam, I wouldn't draw that. So maybe I shouldn't have done that, but just listen to me when I say do not do that because that's not part of the answer for A. I'm just showing you that that's what we're looking for B. So again, we need to find the slope. So plug in 1, 0 into dy dx. Again, using the formula from up here. So we have 1/3 times 1 times 0 minus 2 squared. And that's going to leave us with 4/3 as our slope. So then we plug that into point slope form with our point. So y minus 0 equals 4/3 times x minus 1. And I would just leave it like that. You could distribute the 4/3 and write it in slope intercept, but again, it's not necessary. I like to leave it like this because it makes it easier to plug in a decimal this way. But again, whatever works for you. So then we need to plug in 0.7 because we have to approximate the function value at that point. So 4/3 times 0.7 minus 1. 0.7 minus 1 is 3/10, negative 3/10. I put it as a fraction just because it's easy to cross out, cancel out the 3's here. So then we're left with negative 4/10, which is negative 2/5, or negative 0.4. So that is it. You know what? My green line isn't even that accurate, to be quite honest with you, so I'm just going to totally get rid of it here. Now that I'm looking at it, I don't think that actually helped anything, so I'm going to get rid of it. Because that is not anywhere near negative 4/10, which is the problem you run into when you're estimating using a slope field. But everything else is good. So that's it for 7.5.